Hello everyone. Today we'll be talking about solving equations and inequalities. And this topic is super important for laying down your foundation for Algebra 1, which is a course that can be taken in middle school or in high school. So let's get right into it, solving equations and inequalities. On this side, I have two of the most basic forms of an equation and an inequality. So this is going to be our equation. X is equivalent to 3, and this is our inequality. So equation in and of itself has this part of equal in it. So equation implies that our variable will be equivalent, indicated by our sign, to whatever is on the other side of the sign. And an inequality, if it has the prefix in, usually implies that it's not. And if we put equal after it, not equal. So an inequality is basically a relationship between whatever we have on both sides of the sign, and it's a comparison between these two variables, numbers, expressions, and it compares these two variables and expressions usually on a number line. So if you don't know what a number line is, it looks like this, where we have all of our numbers on a line. It's like this, -1, -2, and -3. And in this inequality, we're comparing x and +2. So our inequality reads x is greater than 2. And the way you can determine greater than or less than, I like to think of it as an alligator's mouth. An alligator is always going to want to eat the number that is greater than so it can get more food. So if the alligator's mouth is pointing towards x, it means that x is going to be greater than whatever value is on this side, which is 2 in this case. You can also think of it as the arrow. So just like I drew the arrow on this side that's pointing this way, our alligator or our sign is pointing towards the right-hand side, meaning that our arrow will be going in that way once we draw our line. So it means that x cannot be equal to 2, but it can be any value that is greater than 2. So this is going to go from 2 to positive infinity. So it can be any value from 2 to positive infinity. Okay, so let's get back on track. I'll quickly delete that so that we have a little bit more space. Okay, so you're going to see that I wrote out a bunch of different equations and inequalities all in the same line. But in actuality, they're all connected to these original equations and inequalities. It's all called simplification and isolation, which are two terms that you're going to be hearing a lot throughout this video. So we'll be learning how to solve these equations and inequalities using our basic math skills, so multiplication, division, addition, and subtraction. And in the end, we're going to come back to this problem if we have time, and we're going to see how this equation can get simplified to this one in the beginning, and how this inequality can get simplified back to this inequality in the beginning, because in actuality, it's all going to be equivalent to one another. We just need to simplify it. So let's move on to one of our first terms that is very important, isolation. So isolation, I just quickly defined it here, is when you take all the other terms aside from the x term to the opposite side of the equation and inequality. So let's get into what that means right now. So we're going to solve a couple of equations and inequalities. So let's take our equation 6x plus 1 is equal to 19, which is also, I just took it from up here so we can see how it gets simplified to x is equivalent to 3. So we have our equation right here. I'm going to change my brush size. Okay. How can we simplify this so that our x term, as I said in the beginning, is isolated? So we're going to look at our other two terms, and we're going to take our one term that is on the left-hand side, and we're going to bring it to our right-hand side. So how are we going to do that? Let me quickly clear this all up. If we want to remove the 1 from this side and bring it to this side, we have to subtract 1 from both sides, okay? So this is a basic rule of math that if you do anything to one side of an equation, you have to do it to the other side of the equation. So if we're subtracting 1 from this side, then we also have to subtract 1 from this side. So now that we get rid of our 1's here, we just have 6x on our left-hand side. But now we have to compute this, 19 minus 1, which is also equivalent to 18. And now we can use our division skills. So if we want to isolate just the x, we're going to have to divide both sides by 6. Now if we do 6 divided by 6, we just get 1. So we can put x right here, and 1 if you need to. And we go back to our basic math skills, we compute this, 18 divided by 6 is equivalent to 3. Now since the 1 doesn't change anything, we're just multiplying x by itself, you can just write it out like this, x is equivalent to 3. So there you have it. It's super easy when you do it step by step. So you can see how our complex equation right here can be simplified to this really simple x is equivalent to 3. And then when you're solving equations like this is going to be your final answer because you have just solved for the unknown variable, and x is our unknown in this case. So now we're going to look at it from a different perspective, from our inequalities. Our computations are still going to be the same. Our basic math is not going to change. It's just we have a different sign in the middle, which means that our variable means something else. Okay, so let's take all the other terms aside from the x term to the opposite side of the equation and inequality. So we have one term here, and one term here. We want to isolate our 4x. So in order to do that, what do you guys think we have to do? We are going to have to subtract the 3 from this side, which means that we also have to subtract 3 from our right-hand side of the equation. And if you guys don't understand what's going on with left-hand side and right-hand side, just think of our sign as the dividing barrier. So this is going to be our left-hand side. This is going to be our right-hand side. And we're going to keep our variable on the left-hand side. Okay, great. So if we're subtracting 3 from the left-hand side, then we also have to do it to the right-hand side. So now we can just cancel these 3's out because that equals 0. And then we have 4x is greater than, now we have to compute this, 11 minus 3, which is 8. And your division is still going to be the same despite the sign in the middle. So we have to divide both sides by 4 if we want to isolate our x right here. So 4 divided by 4 is going to be 1. If you still need it, you can keep the 1 there. And then 8 divided by 4, compute this, we get 2. And then we can simplify this to x is greater than 2. So you guys, that was really simple. We just went from this really complex inequality all the way back to this really easy one, x is greater than 2. All right, so now we're going to do a little bit of a harder equation and inequality, okay? So we have 3x plus 5 is equivalent to x minus 5. So you may notice that now we have x on both sides of the equation. So let's quickly divide this so we don't get confused. So this is our left-hand side, and this is our right-hand side. Great. So now that we have this defined, we need to gather all of the x terms on one side of the equation, and then all of our non-x terms on the other side of the equation. So let's first look at the x terms. I think I want to get rid of the x term from this side of the equation, from the right-hand side of the equation. So what I'm going to have to do is subtract x from both sides of the equation. Now you can think of this as positive x because there's a positive 1 in front of it. It's just you can't see the positive 1. So if I want to get rid of the x to make this value 0, I have to subtract x so that we can cancel out both of our x's on this side. But then that means that we have to subtract x from this side of the equation too, right? So we're going to get 0 here because we basically canceled out the x's. And if I write this out again, we're going to have 3x minus x plus 5 is equivalent to negative 5. So this makes it a lot more simple. Now we just take 3x minus 1x because we have our imaginary 1. And in order to solve this, we basically just subtract the coefficients. It doesn't have to be anything complicated with the variables. So 3 minus 1 is going to be 2. And then we just attach the x back on. 2x plus 5 is equivalent to negative 5. Great. Now we are back to this stage. So all we have to do is isolate our x term. So let's recognize we have one term here, and one term here. Now all we have to do is separate our 2x from the 5's. So in order to do that, let's see what we're going to have to do. So if you guys know what to do, pause the video right now, solve this problem, and then check back, play the video again to see if you got it right. So if we want to get rid of this term and move it to this side of the equation, we're going to have to subtract 5 from both sides. So subtract 5 from this side, subtract 5 from this side. And then this will cancel out and become 0. So we have 2x is equivalent to negative 5 minus 5. And if we go back and think about our negative numbers and how we add and subtract those, we find that 2x is equivalent to negative 10. Because if we have negative 5 plus negative 5, we get negative 10. You can also draw it out on a number line if you're having trouble. But now that we've gotten our 2x isolated, all we have to do is division, simple division. So we're going to divide 2 from both sides if we want to isolate our x. This becomes 1. And then negative 2 divided by 10, let's think of this as 10 divided by 2 is equal to 5. But remember that we have our negative sign in front, so then we attach a negative to our negative 5. So let me clear this up for you guys so that we can get back. Okay, so we've established that this is going to be negative 5. X is equivalent to negative 5. Okay, and this is our final answer. Guys, we just solved a really, really hard equation and we got our answer right away. We just need to remember our fundamental math skills so that we can easily solve it. Okay, now on the other hand, we have a complex inequality, okay? So let's divide this again so that we can establish our left-hand side and right-hand side. So left and right. Great. Okay, so we see that we have 2 x terms again, so it's going to be a little bit complicated again. And we have 2 constants, negative 1 and 5, so it's going to be a little bit tougher than last time because we have bigger values now. So let's start to solve this. So we have 3x and 2x. I think I'm going to subtract 2x this time and bring it to this side. So how do we do that? In order to subtract positive 2x, we're going to do minus 2x from both sides. So we also do minus 2x from here too, which will bring us to 3x minus 2x minus 1 is less than 5, because this cancels out and it becomes 0. 0 plus 5 is 5. So I think I should draw this in a different color. Can't see it. There we go. So it's less than 5. Whatever is on our left-hand side is less than 5. Now all we have to do is solve this. Remember how I said we can just do 3 minus 2 with our coefficients. 3 minus 2 is 1, right? So then we get 1x. And we don't really need the 1 because we know that anything times 1 is itself. So then we have x minus 1 is going to be less than 5. Great. So now let's go back in, and we only have to actually isolate this variable. So in order to do that, we add 1 to both sides to get rid of the 1 here. And then we have to add 1 to this side too. Or you can put it here too. Either way works. So then we get x is less than 5 plus 1. 5 plus 1 is going to be equal to 6. And this is your final inequality. Guys, we sped through that really fast. So if you weren't able to keep up, you can pause the video, see it step by step, or you can even email us to ask for a little bit more help on this certain topic, because I know it can be a little bit tough. But this is going to be our final answer. X is less than 6. So our x value is going to go from negative infinity, all the way from the negative numbers, to positive 6. Okay? So let's look at a special case when it comes to inequalities and negatives. So inequalities and negatives can be a little bit harder. Let's get right into it. So negative 5x plus 1 is less than 11. So let's begin to solve this. How would we solve this? Remember that we want to isolate our x term, so I think I'm going to take this term and bring it to the right-hand side. So if you guys want me to divide it, I'll divide it for you. This is our left-hand side, and this is our right-hand side. So what I'm going to do is I'm going to bring the positive 1 to the 11, which means I'm going to have to subtract 1 from both sides. Okay, so we write out our inequality, negative 5x. We know that this becomes 0. So then I will just draw our inequality sign right here is less than 11 minus 1, 10. We can also put a 0 here, but we know that this will be canceled out. So negative 5x is less than 10. So now you might be thinking, okay, we can just take the negative 5 to this side by dividing by negative 5. Dividing by negative 5, and you might be thinking our final answer would be x is less than negative 2. But in fact, when you're working with inequalities, the only thing you have to change when you're doing this division by a negative number, in this case, negative number division is key. So we're going to do this as normal. Negative 5 divided by negative 5 is 1. And then we have our x. We're going to leave our sign blank for now, so I'm going to put a little circle here for it. And then we're going to divide this side as normal, so compute it. 10 divided by negative 5 is equivalent to negative 2, right? But now, when you divide by a negative, when you divide an inequality by a negative number, you have to switch around the inequality sign that you're using. So this is going to be greater than now. X is greater than negative 2. And that's just a rule that you have to remember, especially when you're computing inequalities and negative numbers, is that whenever you divide an inequality by a negative number, as I've said before, you have to switch around the inequality sign. So let's say our sign was less than or equal to. If you divide by a negative number, this sign is going to be greater than or equal to. If it was less than, this sign is now going to be greater than if you divide by a negative number. So this is going to be our final answer for this inequality. X is greater than -2. Okay, so now we have a little bit of a harder problem. We have x here, and then we have two constants right over here. So first thing I'm going to do is I'm going to have to move my x to this side of the equation. If you guys need to, you guys can divide your equation into left-hand side and right-hand side, but as you get better at it, you don't have to do that. So I'm going to subtract x from this side. So I also subtract x from this side, and I get -2x minus x plus 3 is greater than or equal to, and this cancels out and becomes 0. So 0 minus 3 is equivalent to -3. So then we have -3 on this side. So let's compute this. -2 minus 1. Like I said before, you just have to add or subtract the coefficients. So -2 minus 1 is equivalent to -3x plus 3 is greater than or equal to -3. And now all we have to do is take this to the other side. So we can subtract 3 so that this becomes 0. And then we also have to subtract 3 from this side. So -3x is greater than or equal to -3 minus 3. So -3 minus 3, which is also equivalent to -6. And now comes our tricky part, because we're going to be dividing by -3, both sides. And remember, this is our negative divider. So we're going to be dividing by a negative number, which means that we're going to have our x here. Since this cancels out and becomes 1, we're going to leave a hole or a little space for our sign. And -6 divided by -3, compute this, you get 2. And since our sign was greater than or equal to before, we're going to change it to less than or equal to. We have to flip our sign. And this becomes our final equation, our final inequality, that we get from this complicated inequality right here. Okay, so that sums it up for our lesson today. I included a try it section for anybody who wants to try and attempt some of the problems. You can send your answers to exceledlearning. Email us with your work and whatever answers you have gotten, and we'll get back to you with the correct answers. You can see if you got them right. So just for clarification, I'll go over all of these problems. 10x plus 2 is equivalent to 22, so you're trying to solve for this x variable right here. Remember, the hint is isolation. I'm going to write this at the top, isolation. You need to isolate the x variable, the x term, on whatever side of the equation, of the sign that you want it to be isolated on. Okay, next up, 3x is less than or equal to 45. You're trying to solve for this x term right here. Solve for x. 2 times 2x plus 3 is equivalent to x plus 6. So remember, we want all of the x terms to be on one side of the equation, and we want our x terms to be isolated from all of these other constants. And just for clarification, remember that if anything is in parentheses, such as whatever we have here, it's going to be multiplication. Okay, and solve for x. So -7x plus 20 is greater than 76. So remember, you're trying to solve for this term right here. This one is going to involve subtraction, and a little bit of division. And then finally, what we have is negative 3x minus 2 is less than 2x minus 12. You're trying to isolate these terms, so which means that you're going to have to bring all the x terms to one side of the equation. And then you're going to isolate these constants so that our x term can be set in an inequality with those constants. So if you guys have any questions, do not hesitate to email exceledlearning with all of your questions. Now I'll quickly go over what we went over today. Solving equations and inequalities, we basically defined an equation and an inequality, and then we defined isolation. Right after that, we found out how we can go from a really complex equation or inequality to these really simple equations and inequalities. So in reality, all you have to do is simplify. And then we went over some really complex examples where you have x on both sides of the sign, and you have to do a lot of simplification in this case. And then we went over how inequalities change when they're being divided by negative numbers, such as -5 and -3, and how the sign has to flip when you're doing this division. So, for example, greater than and equal to will flip to less than and equal to. Okay, and then we went over our try it section. So that sums it up for the lesson on solving equations and inequalities today. Please share this video with anyone who you think it might benefit. Like, comment, subscribe. Let us know what you want the next couple of videos to be about, and we will definitely fill you in if you have any questions on anything that we went over today. Thank you.